So hello and welcome again to the videos for Shaughnessy's class. This is Rational Expressions Lesson 7. And once again the standard disclaimer that please attend class because this is just kind of a quick overview. It is not designed to be a full lesson, so hopefully we'll see you in class. For the last couple classes we've been discussing rational expressions, which we know are polynomial fractions essentially. We've discussed non-permissible values, we've done multiplication and division. Now we're talking addition and subtraction. Now, when it comes to addition and subtraction, once again, you've got to remember how to factor and you've got to remember the fractions rules. To add or subtract rational expressions, you need a common denominator. And to find the common denominator, you have to factor it first. You have to factor first, okay? So there's a variety of different ones, okay? And we're just going to start kind of slowly looking at ones that have already a common denominator. So if you have already a common denominator, same with fractions, you just add or subtract the numerators as appropriate. There's a couple things to remember. So let's look at this one. 7x plus 1 over x plus 2 plus 4x all over x plus 2. So you've got this. Well, the denominators are the same. They're constant. They're common denominators. So I look at this and I say, okay, well, I'm going to keep the denominators the same. So it's going to be over x plus 2. And I'm going to add the numerators. So I have 7x plus 1 plus 4x. So I'm going to write that. You don't have to. Okay, as long as you remember how to do this. Now you've got to combine like terms to clean that up. So 7x and 4x are like terms. 7 plus 4 is 11. So I have 11 x's plus 1. And it's all over my common denominator of x plus 2. Once I'm done here, I'm going to look at the factoring and say, can I simplify this? This one I can't, so I'm just going to leave it as is. Okay. Another example, just randomly choosing one, this one with a subtraction. I have 2x squared minus 3 over 5 times x plus 1. So I've got a common factor there. But my next one I'm going to have 3x squared plus 4x all over 5 times x plus 1. So the denominators are the same. So I'm just going to subtract the polynomials. Now, I'm going to write it a little bit differently. Bracket 2x squared minus 3, close bracket, minus another bracket 3x squared plus 4x, all over the common denominator of 5 times x plus 1. So I keep the denominator the same, subtract. The reason I did this is because when you've got a subtraction, often we'll try to see if you're paying attention and remembering that that negative has to distribute through. So if you remember that that negative has to distribute through, then what you're going to end up with is 2x squared minus 3 minus 3x squared minus 4x all over 5 times x plus 1. Now I assure you that if you're looking at a multiple choice question, forgetting to distribute that negative is going to be one of the distractors. It is going to be there. So just be careful that you don't forget this. Now once I do this though, combine like terms, the only two like terms I have are 2x squared and negative 3x squared. So 2 minus 3 is negative 1 x squared. I've got a negative 4x and I've got a negative 3. And that's all over my common denominator of 5 times x plus 1. And that's what I end up with. Now in both of these situations going all the way through, I have to look at non-permissible values. Non-permissible values don't disappear. The nice part is with this one here, x plus 2 can't equal 0. So x can't equal negative 2. That's all I get here. That's all I get at the end. So either way I get the same non-permissible value, so nothing changes. Everything's really nice. Over here I've got the same non-permissible value. I say x plus 1 cannot equal 0. So x cannot equal negative 1. That's my non-permissible value. It comes out of here, and it comes out of the end. So the non-permissible values are there. Okay. The biggest difference is you need a common denominator. add the numerators or subtract the numerators. Be careful when you're subtracting that the negative distributes through. Now, there's also the next level of these things, is the denominators. So this one here. If the denominators are monomials, so they only have a single term, it's a little bit easier than some of the others, but you still need a common denominator, so you still end up having to work that through. Okay, if I do one that looks like this, e.g. 7x over 10 minus 5x plus 1, plus 1 over 6. Okay, so I look here and I need my common denominator. These are monomials, and the nice part is they're just numbers anyway. So I need to find a common denominator for them. Okay, 60 is one of them. There's a better one. You could just find your least common multiple. So if I count by 10, it's 10, 20, 30, 40, etc., etc. And counting by 6, it's 6, 12, 18, 24, and 30. And then 36. 30 is my least common multiple. 30 is also my LCD. Okay, so I'm going to say, what do I need to multiply to this one? 10 times 3. Whatever I do to the bottom, I have to do to the top. Here, what do I need to multiply? 5. Whatever I do to the bottom, I have to do to the top. So cleaning this up, I'm going to have 3 times 7x, or 21x, over 30. Minus, and here I'm going to end up with 25x plus 5, because it's going to be 5 times the whole thing, over 30. And then once all is said and done, now I just subtract. So I'm going to end up with 21x, and it's a subtraction, so I'm going to use these extra brackets, minus 25x plus 5, all over 30. Cleaning that up, 21x, this negative distributes through. So it's going to be negative 25x minus 5 all over 30. 21 minus 25 is negative 4x minus 5 over 30. 30. And there we go. That's my expression. Keeping in mind, I always look at NPVs. In this one, there are no NPVs. The reason? There's no x's in the denominator there, no x in the denominator there, no x in the denominator after all is said and done. So since there's no possibility that x could make that denominator 0, I don't have any NPVs. Now, I could look at a variety of slightly more difficult ones, so let's start here. Okay. If I end up with, e.g., 1 over 2x plus x over 3x. Okay, here's my denominators. Now, in each case there's an x. So since the x is the same in each, the literal coefficient is what we call it. The literal coefficient for the variables is the same in each. I don't need to consider them. All I need to do is look at the numbers. So I'm going to look at the numbers. It's 2, and then it goes 4, and 6, and 8, and it goes 3, and 6, and 9. 6 is my lowest common denominator, or 6 is my lowest common multiple, so my lowest common denominator is going to include the number 6 as well as this x that's common. So that's my lowest common denominator. Okay, going along here, what do I need to multiply to 2x to make it 6x? Well, I need to multiply by 3. Whatever I do to the bottom, I got to do to the top. Here I got to multiply by 2, bottom and top. I get all said and done, I get 3 over 6x plus 2 times x, or 2x, over 6x. Now I just add the numerators, so 3 plus 2x all over 6x. There's my value there. I'd check it to see if it simplifies. It doesn't simplify, so I'm going to leave it at that. I do also need to consider non-permissible values. So out of this one, I get 2x cannot equal 0, which means x cannot equal 0. That's one of the non-permissible values. I get the same non-permissible value out of this guy. 3x can't equal 0. I get x cannot equal 0. And I get the same non-permissible value out of this guy. 6x does not equal 0. So x does not equal 0. So that's my NPV. Okay? And so on and so forth. all that happens is you end up just playing with this. Now there's the negative one as well. Looking at another one slightly more complicated, same basic idea, going through looking at this, e.g. X plus 5 over 3x plus 2x minus 3 all over 2x squared. That's similar, very similar. Monomials, so there's only one term in each. Okay, there's a number and there's a letter. Okay, I go through and look at the letters really quickly. There's 1x here, 2x's here. So I'm going to put 2x's in my denominator. So my lowest common denominator is going to be something x squared. Okay, that one's already there, so that's good. Here I just have to get a little bit more. Looking at the numbers 3 and 2, I find the least common multiple between them. It's 6, so I'm going to use my common denominator of 6x squared. The number and the letters. Okay. Now from there, what do I need to multiply to make this 6x squared? I need to multiply by 2x. Whatever I do to the bottom, I have to do to the top. In this one here, I just have to multiply by 3. The x squared is already there. So what I end up with is 2x times x plus 5 over 6x squared plus 3 times 2x minus 3. Now I've deliberately written this out a little slower, over 6x squared. Before I do that, I'm going to multiply this 2x in, it distributes through. Multiply that 3 in, it distributes through. I'm going to end up with 2x squared plus 2 times 5 is 10x plus, and in this one I'm going to end up with 6x minus 9. That's going to be my two numerators, and I'm going to add them together, and it's all over the common denominator of 6x squared. So then I clean that up by collecting like terms. I've got 2x squared here. 10x plus 6x is 16x, and then there's a minus 9, and that's all over my common denominator of 6x squared. There's what this multiplies out to be. I'd try to cancel it out. It doesn't cancel with anything here, so I'm just going to leave it. Look at the NPVs. Looking from here, I get 3x cannot equal 0. Divide by 3, I'll get x cannot equal 0. I get the same non-permissible value out of that. I get the same non-permissible value out of the final answer. So all in all, those are my NPVs, or that is my NPV, and there we go. Okay. When a monomial denominator is going on, it's just you look at the numbers and you look at the letters. Keep in mind, if this was negative, then I'd have a minus here, I'd have a minus here, and that minus would have to go through. Okay, so I've got examples there. Then, when we get a little bit more complicated, okay, same basic idea. Two rational expressions have a lone binomial denominator. So they've just got binomials in the denominator. Okay, the negative we'll still have to deal with the distributing through. But looking at this, if I end up with something like this, e.g. 2 over x plus 5 plus 3 over x plus 2. Now the x plus 5 is an x plus 5. It goes as a group. You could put it in brackets if you want. They do not separate out. This one is an x plus 2. Okay, it doesn't separate out. Okay, it just leaves it at that. So this thing here, if two rational expressions have lone binomial denominators, means that's all that's there. Okay, we adjust the denominator, but we just use both. So my lowest common denominator is going to have an x plus 5, and I'm deliberately saying that fast, and an x plus 2. Okay, those things go together. Okay, I can't separate the x plus 5, I can't separate the x plus 2. So I look over here and I say, what do I need to add to this x plus 5? In order to make it this, I need to multiply by x plus 2. Whatever I do to the bottom, I have to do to the top. Okay, here I need the x plus 5. Whatever I do to the bottom, I have to do to the top. People often say, well, why don't I just put this up there and this up there? They think cross multiply. It doesn't always work, so don't think of it that way. Try to think of it in terms of what's really going on. If you just look for shortcuts, I promise you, you're going to see questions where the shortcut doesn't work. At any rate, here I'm going to get 2 times x plus 2 over the common denominator of x plus 2, x plus 5. And it doesn't matter what order you write it, it's still the same denominator. Here I'm going to get 3 times x plus 5, and it's all over the common denominator of x plus 2, x plus 5. So cleaning that up, this 2 will multiply in, this 3 will multiply in. So I'm going to get 2x plus 4 over the x plus 2, x plus 5. Plus, here I'm going to get 3x plus 15, and all over the x plus 2, x plus 5. Putting them together, I'm going to add like terms. 2x plus that 3x gives me 5x, and 4 plus the 15 gives me 19. And it's all over my common denominator. I keep the denominator the same, add the numerators. That's what it simplifies down to. I would try to factor it down to simplify it if necessary. Last but not least, I check the NPVs. Really, you probably should do it first. I usually do it at the end. Okay, I know that x plus 5 can't equal 0, so x cannot equal negative 5. There's one of my NPVs. Out of here, I know that x plus 2 cannot equal 0, so I get x cannot equal negative 2. The same things are going on here. I could get that one out of there, this one out of there. So the non-permissible values, there are 2 of them, okay, can be anything but, okay, and you work that out. If I was to look at some more examples, just really quickly, okay, if I was to do a subtraction just for fun, and I do one that looks like this, e.g. 1 over x plus 1 minus 1 over x minus 1. Okay, it's a minus, so I'm going to have to watch for that binomial thing. Okay, I've got an x plus 1 and an x minus 1. They're close, they're not the same. So my common denominator, because all there is those binomials, is an x plus 1, an x minus 1. What do I need to multiply here? Well, I need the missing x minus 1. Whatever I do to the bottom, I have to do to the top. Here I'm missing the positive, or the x plus 1. Whatever I do to the bottom, I have to do to the top. Now, I'm going to multiply 1 times this and 1 times this and do it all in one step, so I hope you're okay with that. I'm going to get with 1x minus 1 over an x minus 1, x plus 1, minus, here I'm going to get an x plus 1 over an x minus 1, x plus 1. So now I keep the denominators the same, as always, x minus 1, x plus 1, and it doesn't matter what order you write those in. I'm going to have this minus this. So I'm going to write that out, because the thing I cannot caution you enough about is forgetting when there's a subtraction that negative goes through. Okay, everybody misses that, or not everybody, but a lot of us miss that. Minus x minus 1 all over my common denominator. If you do this on scrap paper, that's fine. You just need to make sure you keep track of what's going on. So I have 1x minus 1x is 0x, the x's are gone, and I have negative 1 minus 1 is negative 2 all over my x minus 1 times my x plus 1. And so that's what it boils down to. Okay, it ends up being that. Okay, I'd check my non-permissible values. Out of here, x plus 1 cannot equal 0, so x couldn't be negative 1. And out of here, x minus 1 can't equal 0, so x cannot equal positive 1. I'd get the same pieces out of there. Okay, there's that one, there's that one. So all in all, the non-permissible values are the same. Okay. If it gives you a different binomial, or a binomial at least that looks different, then you've got a few more things you've got to keep in mind. Now, I'm just looking for the right sheet of paper because I know I said it somewhere. It's right over here. Here we go. If I look at these, if a rational expression has a different binomial, or you have to factor it first because it's more complicated, then once you have to factor all the denominators first. Once that is done, we can calculate the common denominator by looking at the individual pieces. If a piece has been used, we do not need to use it again. That way we get the lowest common denominator. If we end up using it a couple times, okay, then we get a denominator that's higher, and it just makes it that much more difficult, quite a bit more difficult actually, to simplify. Okay, so if we look at one like this, e.g., okay, 6 over 2x plus 4 plus 9 over 3x plus 6. Okay. First thing I do is I look at those denominators. They are not the same, but I'm going to check the factoring, and you would have checked up above. It just the previous ones we didn't have to. So here I look at the 2x plus 4. I notice a common factor of 2. I pull it out. It leaves me with x plus 2. In this second one, it's 9 over, pull out a common factor of 3. It leaves me with x plus 2. Now, you may see cancellation here, you may not. Okay, I see the 3 and the 1 can cancel, and I can see the 9 and the 3 can cancel. I'm going to pretend I don't notice that. Okay, so if I'm pretending I don't notice that, or if I just don't notice that, I say, okay, that's now factored, so I need to find my lowest common denominator. I've got the 2 and the 3 out in front. I need a common denominator between 2 and 3. So I look for the lowest common multiple of 2 and 3. The lowest common multiple is 6, so that's going to go there. Then I look here and I see an x plus 2. There's 1x plus 2 here, 1x plus 2 here. So since there's 1 in each case, I'm going to use 1. I need an x plus 2 in each case. If you used it twice, you're going to get x plus 2 squared. You're going to get a much larger polynomial. It's a lot harder to factor. This is my lowest common denominator. So from there I say, well, what do I need to do here? To make this 6 times x plus 2, I need to multiply by 3. Whatever I do to the bottom, I have to do to the top. To make this guy 6 times x plus 2, multiply by 2. Whatever I do to the bottom, I've got to do to the top. It leaves me with 3 times 6, or 18, over 6 times x plus 2. Plus 2 times 9, or 18 again, over 6 times x plus 2. 18 plus 18, I add the numerators, I'm going to get 36 over 6 times x plus 2. I think I'm done. Once again, you always remember to cancel. Now this is the first one where it's actually had something to do. 36 is 6 times 6 over 6 times x plus 2. These 6's cancel. It leaves me with 6 over x plus 2. And that's the final answer for this. Keeping in mind, I always look at non-permissible values. I'd look at the factored form. It's always easier to look at the factored form if there is one. So here, the 2 can never be 0, so I don't need to think of it. The x plus 2 cannot equal 0. So x cannot equal negative 2. And that's the same thing I'm getting here. And that's the same thing I'm getting here. So all in all, those are my only non-permissible values. The denominators just get more and more complex. That's all that happens throughout this. Okay, so if I look at this one, just give me a sec. Sorry. Okay. So if I look at one that looks like this, i.e. 2x over x minus 2 minus 3 over x squared minus 4. Okay. I look at this, and the binomials do look different. Absolutely, they look different. So I'm going to try to factor them. I look first at this denominator here, x minus 2. There's nothing to factor. There's no common factor. Those aren't perfect squares. So I'm just going to say, well, it's done. That stays exactly as is. When I look at this denominator, there's no common factor, but I notice that that is a difference of perfect squares. It's x squared minus 2 squared. Okay? So it's going to be, the 3 still stays, first piece plus the second times the first piece minus the second. So I factor it down to there. Now I go looking for my lowest common denominator. I've got an x minus 2. I've also got an x minus 2 over here. Since they've been used, okay, I don't need to use it a second time. I'm just going to use it once. So I know my LCD has the x minus 2. Okay, it's been used. I know I could use it twice. I don't want to. I go along here, there's an x plus 2. I haven't used that one yet, so I'm going to add the x plus 2. Okay, or multiply, I guess. And then there's another x minus 2, but I've already used that. So this is my LCD. Okay, so you just look for the individual pieces. I look at this denominator. What do I need to multiply to this denominator to make it that one? Well, I need the x plus 2. Whatever I do to the bottom, I have to do to the top. Here, to make this denominator that one, I don't need to multiply by anything. So I just leave that. So what I'm going to end up with is 2x times x plus 2 minus 3, and the common denominator is, in each case, x plus 2x minus 2. Cleaning this up, this 2x distributes in, so I'm going to end up with 2 times x squared. 2 times 2 is 4x. Okay, that's what that one is, and it's going to be minus the 3. I check, do I need to distribute it in? There's only one term, so it doesn't really matter. Keep the denominator the same and add the numerators together. Now I'm going to combine like terms. 2x squared plus 4x minus 3. There are no like terms, so it stays just like that. Over my common denominator of x plus 2, x minus 2. Okay. I look at that. There's my simplified form. That's all I need to do. I look at my non-permissible values, and once again always look at the factored form. From here I know that x minus 2 cannot equal 0. So I know that x cannot equal 2. That one there, I know that x plus 2 cannot equal 0. So I know x cannot equal negative 2. And from here, I get the same one. In my final answer, I get the x plus 2, that one, and the x minus 2, that one. So my NPVs remain the same, which makes life nice. And so that ends up being that. Okay. There are lots of other possibilities that you could end up having to do. Keep in mind that what it boils down to is you've just got to make sure that you're careful. Last example before I go, I'm going to make it another subtraction just because they tend to be harder. E.g., I'm going to get 4x plus 3 over 6x minus 3 plus x minus 5 over 6x plus 14. Okay, so I'm looking at this one. Common denominator, or the denominators, they're binomials, they're not the same. Try to factor them down. Here I notice a 3 common, so I'm going to pull it out. Pull out the 3, and I'm going to get 2x minus 1. Here I notice a 2 common. Pull it out. It's going to leave me with 3x plus 7. So I look at that. There's as far as I can factor. I need my lowest common denominator. Looking at the numbers 3 and 2, okay, it's just coincidence that all the ones that I'm randomly grabbing are 3 and 2. Lowest common denominator for those two is 6. Then I've got a 2x minus 1. Then I've got a 3x plus 7. So that's what I need as my lowest common denominator. So I ask myself, what do I need to make this denominator that one? Well, I need to double that 3, so I'm going to multiply by 2, as well as I need a 3x plus 7. Whatever I do to the bottom, I have to do to the top. Here I look at this one, well, I need to triple that 2, so I'm going to multiply by 3. I also need a 2x minus 1. Whatever I do to the bottom, I have to do to the top. Now this one gets complicated, okay, but I can still do it. Now this denominator is going to be 6 times 2x minus 1 times 3x plus 7. Once again, it doesn't matter what order you put that in. And this denominator is going to be 6, 2x minus 1, 3x plus 7. Okay, so the denominators have been adjusted. All I need to do is do this multiplication. Now this 2 distributes into one or both, one or the other, not both. Sorry, one or the other, not both. So I'm going to put it in that one. I'm going to put it in this one. And what I'm going to end up with is 4x plus 3 times 2 times 3 is 6x. 2 times 7 is 14. Okay, that's a plus 14. Doesn't look very neat. Here I'm going to end up with an x minus 5 times a 6x minus 3. Coincidence? Well, not coincidence, but it's the same as what I had there. So I say, okay, now I've got to multiply these out. Now multiplying these out, it's multiplying binomials. Some of you may know the acronym FOIL, first, outer, inner, last. Some of you may multiply in a variety of different ways. I'm just going to multiply them. Hopefully this makes sense. So 4x plus times 6x is 24x squared. Okay, 4x times 14 is going to be 56, so plus 56x. 3 times 6x is going to be plus 18x. And 3 times 14 is going to be 42. That's all over my common denominator. If you're not sure what I've done there, please come and ask. It's multiplying binomials, FOIL, or whatever you want to call it. Various different ways to describe it, and do it. Out of here, I'm going to end up with 6x squared minus 3x minus 30x plus 15. All over my common denominator, 6 times 2x minus 1 times 3x plus 7. Once that's done, keep the denominator the same. 6 times 2x minus 1 times 3x plus 7. And I'm going to combine like terms. 24x squared plus 6x squared. Keep in mind, if that was a negative, I'd have to distribute 2. Okay, so 24 plus 6 is going to be 30 x squareds. Pardon me. Continuing on. I have 56x plus 18x minus 3x minus 30x. So I'm going to have here, I just do that work. So 56 plus 18 minus 3 minus 30. So 56 plus 18 minus 3 minus 30. This is all I'm doing. I'm going to get 41x. And I have 42 plus 15. Add those together, I'm going to get plus 57. And there's my simplified form. This is harder than almost everything you'll see. However, you should be able to do this. Okay? Looking at my non-permissible values, just going back to the beginning, I know that 6x minus 3 can't equal 0. So 6x can't equal 3. Divide by 6, x cannot equal 3 over 6 or 1/2. Other non-permissible value comes out of here. I get 6x plus 14 can't equal 0. So 6x can't equal negative 14. So x cannot equal negative 14 divided by 6 is negative 7 over 3, negative 7 thirds. Okay, so that's what I end up getting. Long story short, this is adding and subtracting rational expressions. The key is the common denominator. Some of them already have the common denominator, and if so, just use the algebra. It's combining like terms, it's factoring, that sort of thing. If the denominators aren't the same, you need to adjust them. If they're monomials, it's simpler to adjust them. If they're binomials and they're different, hopefully they're factored. If they're not factored, you have to factor them before you find the lowest common denominator. This is a very common spot where people have trouble with this course, so I hope that makes sense. If you have any questions, let me know. There are more examples in the class lesson, so if you have any questions, you can start there, and otherwise, have a great evening.